Hello friends, this is our programming language translator assignment. This assignment has been done by me, Suyash Suptankar 13BCE0044 and my friend Rahul Anand 13BCE0209 for our faculty Professor Kannadassan R. The question is give the criteria for machine independent optimization and the machine independent optimization can be obtained using the following criteria. The code should be analyzed completely and use alternatively equivalent sequence of source code that will produce a minimum amount of target code. Use appropriate program structure in order to improve the efficiency of target code. Eliminate unreachable code from the source program and move two or more identical computations at each place and make use of a result instead of each time computing the expressions.
The question is to explain global data flow analysis. It is to collect information about the whole program, distribute the information to each block in the flow graph. Data flow information is the information collected by data flow analysis. Data flow equations is the set of equations solved by data flow analysis to gather data flow information. What is data flow analysis? When doing data flow analysis, we must be conservative, which is do not consider information that may not preserve the behavior of the program. Be aggressive, that is to try collect information that is as exact as possible so we can get the greatest benefit from our optimizations. Global iterative data flow analysis. It is global, which is performed on the flow graph, and the goal is to collect information at the beginning and at the end of each basic block. Iterative, to construct data flow equations that describe how information flows through each basic block and solve them by iteratively converging on a solution. Components of data flow equations. They are the sets containing collected information in set, which contains the information coming from the base block from outside. Generation set, which contains the information generated and collected within the BB. Kill set, which contains the information that due to action within the BB will affect what has been collected outside the BB. Outset, information leaving the BB. Now the functions used are transfer functions, which describe how information changes as it flows through a basic block. Meet functions, which describe how information from multiple paths is combined. The algorithm is typically a bit vector is used to store the information. For example, in reaching definitions, each bit position corresponds to one definition. We use an iterative fixed point algorithm. Depending on the nature of the problem we are solving, we may need to traverse each basic block in forward, top down or backward direction. The order in which we visit each BB is not important in terms of algorithm correctness, but it is important in terms of efficiency. In and out sets should be initialized in a conservative and aggressive way. The algorithm is as follows: initialize gen and kill sets, initialize in or out sets depending on direction. While there are no changes in and out sets, for each BB apply meet function and apply transfer function. A typical data flow equation looks like this: out of S equal to gen of S union in of S minus kill of S, where S is the statement, in of S is information goes into S, kill S is information get killed by S, gen S is new information generated by S, out S is information goes out from. The notion of gen and kill depends on the desired information. In some cases, it may be defined in terms of out equation is as solved as analysis traverses in the backward direction. Data flow analysis follows control flow graph. Equations are set at the level of basic blocks or even for a.
The question is construct a predictive parser table for the given grammar. The grammar is S tends to open bracket L close bracket or S tends to A, and L tends to L comma S or L tends to S. For the given grammar, since we have left recursion in the form of L tends to L comma S, we will have to remove the left recursion before we can create the LL1 parser table. In order to construct the LL1 parser, we have to remove left recursion from the grammar. Left recursion occurs when the first symbol of a non-terminal is the same as the non-terminal. For example, in the previous slide, L tends to L comma S. So to remove left recursion grammar, we get this new grammar. Now generating the first and follow for the non-terminals in this grammar, the table is presented as follows. The first for S is close bracket A and the follow is a dollar symbol and comma. Similarly, the follow and first for L and L dash is given. We start with an empty passing table. The rows are non-terminals and the columns are terminal as given. We shall be filling this table following the rule of LL1 parser table. The rule is as given. For each production A tends to alpha in the grammar. For each terminal A in first of alpha, we add the production A tends to alpha in the table in the position M of A comma A. If epsilon naught is present in first of alpha, then for each symbol B in follow of A, we add A tends to alpha in M of A comma B. Using this rule, we fill out the table. For example, since open bracket is the first of open bracket L close bracket, we add S tends to open bracket L close bracket in M of S comma open bracket. Similarly, we fill out the other table as is shown. Since the table has more than one entry in a cell, this table is not an LL1 parser table. Thank you.